For the second method, we are going to make use of the last function, which is h. Okay? For h, we know what is the domain. The domain of h is from minus infinity to 0. Which means that if I were to put minus infinity to 0 into h, what that comes out is going to give me the range of h. If I were to sketch the graph of hx, the graph is going to look like this. It has an oblique asymptote, y is equal to x. It has a vertical asymptote, x is equal to 0. And we are talking about x to be less than or equal to 0. So my graph of h will look something like this. And this maximum possible point here, is minus 1 and minus 2. Okay, this is the graph of y. This is the graph of y is equal to hx, which means that the range is going to be from minus infinity all the way until minus 2. I want to train my eye so that visually I'm always capturing the y coordinates to be the range. So the range represents all the possible y coordinates that I can see from minus infinity to minus 2 inclusive. Minus 2 inclusive. Okay? But this is just h. And I know h is not happening here. H is being connected to f. So I want to do a simulation. I want to do a simulation of what that is happening in the composite function as compared to h existing as an independent function. So how can I do this simulation? Absolutely simple. I just need to change what that goes into h. I cannot change what h can receive, but I can change what goes into h instead. What goes into h? What goes into h is what comes out from f. Agree? What goes into h is what comes out from f. Which means that rather than minus infinity to 0 going into h, I'm going to let minus infinity to minus 1/4 inclusive of 1/4. I'm going to let this set of value go into h instead. Okay? So my aim is now changed. Instead of getting the range of h, if I believe that if I can let this go in, what that comes out is going to be exactly the same as what that comes out here, which is going to give us the range of hf. And now on this graph, instead of going from minus infinity to 0, I'm going to go from minus infinity to minus 1/4. And that is going to be from here, x minus infinity to x minus 1/4. Let's say here. So this point, x is minus 1/4, and the corresponding y coordinate is minus 17/4. Okay, so we have this. So x is going to be from there all the way until minus 1/4. Visually, again, I capture the output as the y coordinate. So what is the range of hf? It is from minus infinity all the way until minus 2 inclusive. Minus infinity all the way until minus 2.